Okay, so simplifying complex rational expressions. All right, Roman numeral 1, we're going to start by just writing out the basic steps so that if you get home and you don't know what to do, you can go over the steps and walk yourself through it. So number 1, you're going to simplify, and by simplify we mean factor, the numerator. Number 2, you're going to simplify or factor the denominator. And sometimes this might involve adding things together. That's part of simplifying. And then this is the money step, the money move. You're going to eliminate the denominator using a reciprocal. So eliminate the denominator using a reciprocal. And then step 4, because you're multiplying the bottom by the reciprocal, you also have to multiply the top by the same thing. So multiply the numerator by the same expression, whatever that expression was. And then now that you have no more double fraction, everything should be factored. So see if you can simplify some of those factors out. And a lot of these questions are kind of nifty because they simplify like way down. Okay, so these are some tips that I would recommend to make things a little easier for you while you're doing them. The first one is to make the primary fraction bar heavy so that you don't get mixed up with what's on the top, what's on the bottom. Because if you don't make the fraction bar heavy, sometimes it's hard to figure out what's in the numerator and what's in the denominator because there's just so many pieces to these. So make it heavy and dark. Another suggestion is to write ones in the denominator of whole numbers. That way your whole numbers are lined up with the fractions and the tops are together and the bottoms are together. So when you're blending whole numbers and fractions, writing a 1 under your whole numbers kind of helps keep clear what's on top and what's on bottom. Okay, and then the last suggestion I have for you is, and we've been doing this all along, is to write your multipliers as n over n. You know, x plus 3 over x plus 3 or 5 over 5. And again, that just helps you line things up and not leave anything out. Okay, so what we're going to do is I'm going to start with an easy example, and then we're going to go more challenging. So we're going to start with a really straightforward one, which is 2 over 1 over 3x. Okay, so using the suggestions, the tips, let's put 2 over its invisible 1, make a nice big heavy fraction bar, and then put the 1 over 3x under it. This way you can see what's on bottom and what's on top. So we would normally factor the top and factor the bottom, but 2 is a prime number. It doesn't factor anymore. And 3 is a prime number. It doesn't factor anymore. So we don't have to factor. There's nothing to factor. So we're ready to go to the elimination step. To eliminate the bottom, you're going to multiply by its reciprocal, which is 3x over 1. Now that means you have to multiply the top by 3x over 1, and you can see how putting the 2 over its invisible 1 really helps it line up. So when you multiply a number by its reciprocal, it divides to 1. So the whole bottom of this is now equal to 1, so we can disregard it. So the last thing we need to do is just simplify the top. 2 times 3 is 6x, and we do not have to put our answer over 1. So that's the basic steps, is factor top and bottom, multiply the bottom by its reciprocal, eliminate it, multiply the top by the same thing, and simplify. All right, so let's go a little bit more complicated. That's kind of like the ones that we've done. Okay, we're going to do 3 over x minus 4 all over 1 over x minus 4 plus 3 over x plus 1. There's our big, heavy middle fraction bar. Okay, so this is going to combine what we've been doing for the last couple days with fraction division. So on this one, when we simplify, the top is already simplified. X minus 4 doesn't factor anymore, and 3 is a prime number. So 3 over x minus 4 is exactly the same. On the bottom, though, to simplify, we need to add the two fractions together, which means we need a common denominator. So the left one has an x minus 4, the right has an x plus 1. So on the left, we're missing an x plus 1, so we multiply by x plus 1 over x plus 1. On the right, we're missing an x minus 4, so we multiply by x minus 4 over x minus 4. So now that the bottoms are the same, we're going to put the two tops over one bottom. So I've got x plus 1 from the first one, and then I'm going to distribute the 3 plus 3x minus 12 all over x plus 1, x minus 4. Okay, finishing the bottom for our simplifying, let me rewrite the top, 3 over x minus 4. 3x plus 1 is 4x. 1 minus 12 is negative 11 over x plus 1, x minus 4. Now, this is where you want to ask yourself, can you refactor the top? Because we have a new numerator, but 4x minus 11 is already factored. So there's nothing we can do to expand that. So we're ready for the elimination step. To eliminate the bottom, you're going to multiply by the reciprocal, which is x plus 1 times x minus 4 all over 4x minus 11. And that means you're going to multiply the top by the same thing, x plus 1, x minus 4 over 4x minus 11. So we've multiplied the bottom by its reciprocal, the top by the same thing. On the bottom, all of the factors cancel out. The bottom is now equal to 1. So we can disregard it. On the top, I have an x minus 4 on the bottom and the top, so I can cancel the x minus 4s. And I'm left with 3 times x plus 1 over 4x minus 11. And it's done. Any questions about that one? Yeah.
Why didn't you multiply the 3 through the parentheses, like 3x plus 3?
Because we're just leaving it in factored form. Just depends on what form you want to end with. All right, let's do another one. One more step complicated. So 2 over x minus 1 all over 4 over x minus 1 plus 1 over x. Okay, so your first step is to simplify and factor the top and the bottom. 2 is already factored, and x minus 1, that's as far as it will go. So on the bottom, we need to add the two fractions together. So start by factoring the bottoms. Well, x minus 1 is factored. X is a monomial factor. So we're going to get the common denominator. This first fraction is missing an x. So we're going to multiply by x over x. The second one is missing an x minus 1. So we're going to multiply by x minus 1 over x minus 1. Now that the bottoms match, we can put the bottoms over one top. Let me just rewrite the top, 2 over x minus 1. So I've got a 4x. And then when you distribute the 1, of course, nothing changes. So plus x minus 1 all over x times x minus 1. So we combine the tops over one bottom. And then I'm going to finish simplifying and see if it refactors. So 2 over x minus 1 all over 4x plus 1x is 5x minus 1 over x times x minus 1. And 5x minus 1 does not factor anymore. So that one is done. So we have simplified the top and factored it. We've simplified the bottom and factored it. Now we're going to eliminate. So multiply the bottom by its reciprocal. So x times x minus 1 over 5x minus 1. And multiply the top by the same thing. X times x minus 1 over 5x minus 1. So anytime you multiply something by its reciprocal, it all cancels out. So the x's cancel, the x minus 1's cancel, and the 5x minus 1's cancel. So the whole bottom equals 1. So all we have left now is the top. And looking at the top, I have an x minus 1 factor on the top and the bottom. So I'm going to eliminate those. And that leaves me with 2x over 5x minus 1. And that is our answer. All right, last one we're going to do. And one baby step more complicated. So we're going to do 2x over 3 minus 2 all over 1 plus 12 over x. This one gets people because we've got whole numbers and fractions mixed together. But remember, just take the whole numbers, put them over their invisible 1, and then everything lines up really nicely. So on this one, we need to add the tops together and refactor, add the bottoms together and refactor. So this has a 3, that has a 1. So the second one is missing a 3. So we multiply by 3 over 3. So that gives us 2x over 3 minus 6 over 3, which add the tops over one bottom, 2x minus 6 over a single 3. And then refactor if you can. I can factor a 2 out, and then I've got x minus 3 over 3. So sometimes you might want to do everything on top first and then everything on bottom second, instead of bouncing back and forth, whatever your preference is. So on the bottom, one of them has a 1, one has an x, so multiply the first one by x over x. So that gives me x over x plus 12 over x. Add the tops over one bottom, x plus 12 all over x, and that is as simplified as it gets. Okay, I'm out of space there, so I'm going to rewrite it. 2 times x minus 3 over 3 all over x plus 12 over x. Okay, so we're ready for the elimination step. We're going to multiply the bottom by its reciprocal, so times x over x plus 12. And we're going to multiply the top one by the same thing, x over x plus 12. The bottom all divides to 1. And so all we have left is the top. And nothing here is going to cancel out. So what you do is you push the monomials to the front and multiply the monomials back together, and then just leave the factors. So I'm going to push the x to the front. So 2x times x minus 3 all over 3 times x plus 12. And that is as simplified as we can get it. So I wanted to show you how to do one side by side. You can do them vertical or horizontal. You can do all of the top, all of the bottom separately or bounce. Those are just things you can figure out as you get better at this. All right, are there any questions before we wrap this up?